All right, let's look at example 2 using our shell technique, and we'll compare it with our washer and the shell to see which one we want to do again. So we're going to find the volume of the solid. Again, have my same region here, y equals x, 4x minus x squared, but we're going to revolve this around the line x equals -1, this green line right here. Okay, so if we examine this, if I want the washer technique, we have to have a reference rectangle perpendicular to our axis of revolution. But again, you can see capital R of x and little r of x touches the same function. So we'll have to take an account from here to here. Then my reference rectangle will touch the red curve to the blue. So that's definitely two separate integrals to work it with. That's going to be way too much work. Plus, you're going to have to solve these for x, and there's two x's there. That'll make it more time consuming. So I'm going to say let's flush the washer technique. We're not going to use it. Let's use the shell technique. Let's build in our parallel reference rectangle. All right, there's my delta x. Good. We don't have to create an integral and integrate with respect to y. We have everything already solved for y, so that will be less work. And if you notice, my rectangle touches the blue down to the red, blue to the red, blue to the red, blue to the red, blue to the red, all the way to these 2 points. So again, that would mean one integral. And as I said, our equations are already solved for y. So we're going shell technique. There's my shell. There's my radius. And my radius is going to be, let me back it up so you can see it, the x coordinate plus one extra unit. That's the x right function minus the -1. That makes it the x plus 1. There's my radius. My height, that will be the blue function minus the red curve. So 4x minus x squared minus x. That's my height. And of course, we can go 4x minus x and make that into a 3x. So 2 pi will integrate from a to b, which will be from 0 to 3. We found those intersection points previously. So here's the x plus 1 for the radius. Here's the 3x minus x squared, combining those together. We'll just FOIL this out. We get negative x cubed plus 2x squared plus 3x. All right, and we'll get what we combine like terms. You had your 3x squared and a minus 1x squared. That created the 2x squared, in case you don't see it there. All right, so let's integrate this. So 2 pi times negative x to the 4th over 4 plus 2x cubed over 3 plus 3x squared over 2. Again, from starting with 0, nice. Those will all cancel out, so we'll just plug in the 3. Negative 3 to the 4th over 4, or negative 81 over 4, plus 2 times 3 cubed over 3, or you can simplify it to 18. 3 times 3 squared over 2, 27 over 2. Again, let the calculator do all the work. We get 45 over 4 times 2 pi. 2 goes into 4 twice. 45 pi over 2 units cubed. My next example, we're going to find the volume of the solid region bounded by x equals 0, y equals 2, and y equals the square root of x, with the revolution generated by revolving the region around x equals -3. So I'm going to draw in all my lines. Here's x equals 0 in purple, y equals 2, the horizontal line. The blue, that's my square root of x. My green, x equals -3, that's where we're going to revolve the shape around. So we're looking at this kind of like curved triangle part there, right? Okay. And y equals 2 is going to hit the square root of x function at 4, 2, because the square root of 4 is 2. So I already found that point of intersection. And, well, washer technique. Let's check this. Perpendicular to the green line. That's this right here. So that's going to be blue curve, our squared. That's my capital R. Purple is my little r. So that's going to be blue curve, R, purple curve, little r. All right, now because I have a horizontal with a reference rectangle, which is going to be a change in y, we need to change this equation and solve it for x, so I square both sides. So that radius is going to go from y squared minus the negative 3, so that's y squared plus 3 for my r. Little r is going to stay constant. It's going to be a value of 3 the whole time. So we'll plug those in, and we have the binomial y squared plus 3 being squared minus a 3 squared. Not too bad. Very easy to resolve this. I have nothing but polynomials to integrate. I'm going to finish the washer technique because I think right now this is looking okay. My lower bound and upper bound will go from 0 to the y equals 2 line. So we'll square this. That's going to be y to the 4th plus 6y squared plus 9. With this minus 9, even better, we're canceling out terms. So I only have to integrate 2 terms. So we'll have y to the 5th over 5 plus 6y cubed over 3, which we can reduce that to 2y cubed. Again, substituting in the 0 for the lower bound zeroes everything out, so we just got to plug in the 2. 2 to the 5th over 5 plus 2 times 2 to the 3rd. That's 32 over 5 plus 16. Calculator tells me that's 112 over 5. Multiply the pi, there's my units cubed. So this case, the washer technique was relatively painless. That's okay. Shell technique, we can still do the shell technique real quick. I have my formula. I have to be parallel to the green line, which is my axis of revolution. Well, all right, so here, r of x, my radius will be the x coordinate plus 3 more. So that's going to be x plus 3. My height is going to be the red curve minus the blue, which will be the 2 minus the square root of x. So there's my r. I said 3 plus x or x plus 3. 2 minus the square root of x. This, looking into the future as I set it up, could be a little bit more difficult because now I'm dealing with square roots here in my integral, which means we'll have to change that to a fractional exponent. But we're going to FOIL it first, or you could change it to x to the 1/2. Either one's fine. As I FOIL this, I get 2x minus x times the square root of x plus a 6 minus 3 times the square root of x. Now, this is x to the 1st times x to the 1/2. This becomes x to the 3/2. This becomes minus 3 times x to the 1/2. So when we integrate this, we're going to get 2x squared over 2, or x squared. Add 1 to 3/2, that's x to the 5/2. Divide by 5/2 is multiplying by the reciprocal 2/5, plus 6x. Add 1 to 1/2, that's going to be 3/2, multiplied by its reciprocal 2/3. Well, the 3's cancel out, leaving me a 2. Again, nice to put in a 0 for your lower bound. Everything's going to cancel out, so we just got to plug in the 4. So here, I'm sick and tired of crunching the numbers. I'm just going to plug in 4 squared minus 2/5 times 4 raised to the 5/2 power, plus 6 times 4 minus 2 times 4 to the 3/2. Just enter it in the calculator, and it gives me a fraction of 56 over 5. Which I multiply to my 2 pi. 2 times 56, notice it's the exact same answer. It better be. They're both the same 3-dimensional solid. All right, so sometimes the washer technique, based on the amount of work, was just as easy as doing the shell technique. So on the test, I will tell you, I want to Find the volume, buy the disc method, buy the washer, buy the shell. Then I'll ask you to find the volume, and I won't give you a technique. You tell me which technique you're going to use, commit to it, find the answer. If you don't like it, erase it, tell me that you're doing a different technique, and then commit to it.